Low-Tech Video 1.3. So a little bit about functions. Functions are just a way to describe a mathematical object that you can graph on the coordinate plane. So these might be three diagrams that you're familiar with. The input is x, you put it into a little function machine. A lot of times your teachers made you guess what does the machine do, and it gives you an output. Other words you might be familiar with, domain and range. So the domain is just the x values. The range are the y or the f of x values. And here's our notation. This is called Euler's notation. Euler you will hear much about for many years and added a lot to the study of deterministic mathematics, which is what you are doing for a while until you take your AP Stats class or Stats in college. In any case, here's the input, here's the output, function notation. So let's just briefly look at that. Hopefully it's a review for most of you. Here we've got inputs and outputs. So this is looking at an input. This just says where there's an x, plug in a 4. So for this, all you're going to do is evaluate -1/2 4 squared plus 5. I'll leave that work for you to do. Here, again, you're just going to replace, now with this function, you're going to replace the x with a 9. So it's going to be 4/3 9, minus 6. Let's do this one just to make sure you're okay with multiplying fractions and squaring them. So f of 2/3, that means we're looking at evaluating -1/2 2/3 squared plus 5. 2/3 squared, oh, we know how to multiply fractions. It's just 2/3 times 2/3 straight across, 4/9. So -1/2 times 4/9 plus 5. Reduce. So we're at -2/9 plus 5. I guess I didn't give you enough room. The dreaded common denominator. The common denominator is going to be 9. So that means -2 plus, 5 is the same as 45/9. So our answer is 43/9. I'll leave this one for you to do as well. Let's just do a couple of these. Let's do this one. Now you've been given an output and you need to find the input. So these are, when I give you an input, these are evaluate questions. You're just doing arithmetic. There's no solving. But here, you're solving. So if we say, what's the x values where f of x equals -3, this is just substitution again, just like Unit 1, we're substituting over and over and over again. So f of x is the same as -3. So -3 equals -1/2 x squared plus 5. First thing we want to do, we're trying to isolate x, so we're going to subtract 5. So we're at -8 equals -1/2 x squared. Multiply by the reciprocal. Make sure you take the negative with you. 16 equals x squared. Oh, we're taking the square root of both. But when you actively take the square root, we have to consider plus or minus. So it's really important when you're looking at what are two values in which x squared yields 16, both 4 squared equals 16, but -4 squared also equals 16. And I'll leave these for you to do. But of course, you look at the key online, so please check your work as you go. Because functions are just mathematical objects that can be graphed on the coordinate plane so they can have an algebraic form and a graphical form. We can do operations on them. So we can do arithmetic on them. So we can add functions, we can subtract functions, we can multiply functions, we can divide functions, and you're going to see there's even more operations that are particular just to functions. So here we've got two functions as an example. We can add them, we can subtract them. Here we can multiply them and multiply them again. I think this is the one you might need the most review with, so let's do this one. If you're going to multiply these functions, again, you can think of it as just substitution. We're going to take 3x plus 2, 2x minus 5. It seems like some of you have learned how to FOIL, some of you have learned how to double distribute. It's all the same thing, it's just a matter of what Algebra 1 teachers call it. So I'm just going to write out your solution here, right? So many of you think of it like this. So we're at 6x squared minus 15x plus 4x minus 10. Be sure to simplify and combine like terms. Oops. And so you end up with this trinomial. Let's not forget, when you multiply negative 8x to the 4th times 5x cubed, let's see, we know the coefficient is negative 40, but we have to remember, do we add the exponents or multiply? Oh, when we're multiplying these two things, we add the exponents. We're at x to the 7th. So please check your work, and I'm here for questions if you have them. Let's remember how to divide a function by another function. Let's do this one. It's a little harder. Again, I don't know. I definitely need to research other video options. This one has gotten wonky at me this year. So if we take this one, we want f of x divided by g of x. What we're doing is negative 12x to the 5th plus 8x squared plus 5 over 4x squared. We could leave that, but the point of this is to remind you of some of the basic other skills that you learned in Algebra 1. So if we take this trinomial and divide it by a monomial, we can think about it as three different things. It's this, divided by this, divided by this. So we're really looking at negative 12x to the 5th over 4x squared plus 8x squared over 4x squared plus 5 over 4x squared. Well, this doesn't reduce, but these two we can reduce. The coefficients here turn into negative 3, and x to the 5th divided by x squared is x cubed. So this term becomes negative 3x cubed. Here, the x squareds reduce to 1, and 8 over 4 is 2 plus 5 over 4x squared. So functions are all about inputs and outputs. So we just looked at some algebraic ways of seeing functions in terms of f of x. But we could look at these inputs and outputs in a table form. So let's take a look here. If here describes all the inputs available and all the outputs available for f of x. Here's the same for g of x. So if they're asking us questions, it's just wonky this year. I don't know how the software has changed, but try to ignore that. So if they're asking us for f of 1, well, what we need to notice is 1 is an input value. So we need to come up here to the input line, and we see when the input is 1, the output is 2. These are just operations, but we could do one just to get us started. Let's see, f of 0 times g of 3. This is an input. Let's look at f of 0. When the input is 0, the output is 3. And for this one, for g, when the input is 3, the output is 5. So that yields 15. We can also look at functions in graphical forms. So for instance, sorry, this is frustrating at best. So we can look at this g of 5, and so they're saying the input is 5 and they're asking for the output. Let's see, this is our g function. I'm going to make it red. And so when they're saying the input is 5, and I'll tell you, these are just all integers. We're not trying to get fancy. We're just trying to get the idea of what it would be. It looks like the output is 2. How about this one? I'll make it green. When the input is 3, so now we're on the f function. When the input is 3, the output is 1. So these are just input-output questions. But we could also ask other questions. For instance, let's look at this one down here. If f of x, if the output is 4, oh, the output is a y value. So that's basically saying, when is y equal to 4? Oh, that's our horizontal line from section 1.1. So let's look at that. Here's a horizontal line that's y equals 4. What they're asking for is, what are the input values when the output is 4? So it looks like it happens here and it happens here. Oh, that's just our intersection question. So it looks like it happens at 2 different places when x is -1 and when x is 5. We're going to stop there and go to a new video for the rest of the packet.